Now let's solve the exercise 4.2. Check whether 1,25,496 and 1,25,433 are divisible by 6. So one example I'll solve and this example you have to solve. Yeah, so to check whether a given example is divisible by 6 or not, first we shall check whether given number is divisible by 2 or not. So let's write, as the number 1,25,496 ends in 6. Okay, that is even number. Therefore, this number is divisible by 2. Now let's check whether the same number is divisible by 3 or not. To do that, we have to add all the digits. Sum of all digits equals to 1 plus 2 plus 5 plus 4 plus 9 plus 6, that is equal to, we'll get the sum 27, and 27 is divisible by 3. Thus the number 1,25,496 is divisible by 2 as well as by 3, therefore it is divisible by 6. Since it satisfies the divisibility of 2 and 3, therefore it is divisible by 6 also. So I hope you have understood and you have to solve this example. Now let's check whether 79,968 is divisible by 12. Okay, so to check whether the given number is divisible by 12, we have to check the divisibility of 3 and 4. So what is the divisibility rule of 3? The sum of these digits should be divisible by 3. And what is the divisibility rule of 4? Last two digits should be completely divisible by 4. So let's find the divisibility of 3. Yeah, so sum of all digits here, 7 plus 9 plus 9 plus 6 plus 8, that equals to 39. Thus 39 is divisible by 3, hence the given number is divisible by 3. Now to check the divisibility by 4, last two digits should be divisible by 4. So it is a 68 and 68 is completely divisible by 4. Okay, just see here. 68 divided by 4. So 4 ones are 4, remains 2, and 4 sevens are 28. Thus we'll get answer 17. Therefore the number is completely divisible by 4. Therefore, this number is divisible by 12. It satisfies both the divisibilities. Therefore, the number 79,968 is divisible by 12. Even we have the rule of checking divisibility by 25. When the number ends in 25 or 00, then such a number it will be divisible by 25. Okay, so all these are the checking divisibility rules. And remaining examples on about checking divisibility of 15 and 18 you have to solve the way I have solved for 6 and 12. In the same way you have to try for the remaining numbers, that is 15 and 18. So now let's see the next part of our chapter, that is prime and composite numbers. So let's see prime numbers. The numbers that are greater than 1 and have only two factors, that is 1 and the number itself, are called prime numbers. Yes, so there are few numbers, for them there are no factors other than 1 and itself. So such numbers are called prime numbers. And there are 24 prime numbers, and the prime numbers are listed here. Between 1 to 100 there are only 24 prime numbers. So here the numbers are listed, that is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. All these numbers are prime numbers, and there are no factors or other numbers which divides them exactly. Like for 2, we can divide by to the 2 by 2 only, or by 1. There is no other number which divides 2, or there is no other number which divides 3 other than 3 and 1, isn't it? So these are the prime numbers. Now let's see what are composite numbers. The numbers which are having more than 2 common factors, okay, such numbers are called composite numbers. And one is neither prime nor composite, isn't it? Which is a composite number which should have more than 2 factors, okay, more than 2. So I'll tell you one example. Just say 6. Okay, example 6. If you see the factors of 6, just see it can be written as 2 3s are 6 and 6 1s are 6. So, how many factors does it have? 1, 2, 3, 4. It is having 4 factors. Therefore, it is a composite number. But 2, 3, 5, 7, these are not composite numbers. Why? Because they are having only 2 factors, isn't it? That is itself and 1. So, now even number. What are even number? The number which divide, the number which is divisible by 2 are called even numbers, and the numbers which are not divisible by 2 are called the odd numbers. Or you can also say the number which ends in 0, 2, 4, 6, 8. Okay, so such a numbers are called even numbers, and the number which doesn't ends with 0, 2, 4, 6 or 8, such a numbers are called odd numbers. Now we are having here twin primes. A pair of prime numbers that have only one composite number between them is called twin prime numbers. Okay, so 3 and 5 are prime numbers, and between 3 and 5 there is one composite number, that is 4. Isn't it? 3, 4, 5, we count that way, isn't it? Therefore, 3 and 5 are the twin prime numbers. Even here also, 5 and 7 are prime numbers, but the number which falls between 5 and 7 is a 6, and 6 is a composite number. Okay, so the pair of such numbers are called twin primes. Now we have co-prime numbers. When two numbers have only one as a common factor, then these numbers are called co-prime numbers. So just see here, if you find the factors, okay, of 4 and 5, okay, then there will be no common factor other than 1. Just like I'll write the factors of 2, factors of 4. Factors of 4 are 2 into 2 equals to 4, and 4 into 1 equals to 4. Okay, and let's say factor of 5. Factor of 5 are only 2. 5 into 1 equals to 5, isn't it? So factors of 5 are 5 and 1. Factors of 4 are 2, 4 and 1, isn't it? So among 2, 4, 1 and 5, 1, we have 1 as a common factor, isn't it? So such numbers are called co-prime numbers. The numbers which are having 1 as a common factor are called co-prime numbers. Now prime factors. What are prime factors? So finding or representing number as a product of prime numbers. Okay, representing given number as a product of prime factors is called prime factorization. And prime factorization, here we have two methods of finding factors: a repeated division method and factor tree method, you might be knowing. So first we shall start with finding prime factors, okay, for 72, 96 and 108 by a repeated division method. So for that, let's see what to do. First, let's find the factors of 72. As it ends in 2, so it is divisible by 2, and 2 is the prime number. So let's divide. 2 3s are 6, remains 1, 2 6s are 12. Then 2 1s are 2, 1 remain, has become 16, 2 8s are 16. 2 9s are 18, and now we can divide this 9 by 3, as 9 is not divisible by 2. So 3 3s are 9 and 3 1s are 3. Accordingly, we have got the factors of 72 as 2 into 2 into 2 into 3 into 7. So let's list here. 72 equals to 2 into 2 into 2 into 3 into 3 are the factors. Similarly, we shall divide 96. As it ends in 6, it is divisible by 2. Therefore, 2 4s are 8, 2 8s are 16. Then again it is divisible by 2. 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6s are 12, then 2 3s are 6, and last one 3 1s are 3. Okay, so here we have to draw the lines. Means there will not be any confusion. Okay, so what are the factors of 96? The factors of 96 are 2 into 2 into 2 into 2 into 2. So how many times 2? 1 2 3 4 5. 1 2 3 4 5 into 3. Okay, even 1 is also there, so 1 is to 1. So even 1 is also the factor. Okay, you can write that also. Okay, so this is how we find the prime factors. So similarly, you can find for 108 also. Similarly, I have found for 108, and here we shall list the factors of 108. Now if you see here, the factors are all prime, isn't it? 2, 2, 3. Okay, 2, 2, 3, 2, 2, 3. There is no composite number. You should never use composite number to find the factors. Always you should start with prime numbers, that is from 2, 3, 5, 7. Right now the reason behind learning checking divisibility rules is the same. You should understand about the numbers, by which number the given number will be divisible, and by thinking that you have to start finding the factors. Here we have another method of finding prime factors, that is a factor tree method, and we shall solve example from exercise 4.3. Draw a factor tree to show the prime factorization of 420 and 72. So let's first find the prime factors of 420. So we have to express this number as a product of prime number and a composite number. Okay, so let's divide this 420 by 2. When we divide by 2, 2 is a prime number. So I'll mark the composite numbers with the pink color. So when I divide this by 2, 2 2s are 4, 2 1s are 2, 2 0s are 0. So it is a composite number. Now this composite number again I will represent as a product of prime number. Okay, prime and composite numbers. So let's further divide. So by 2, as it ends in 0, it is divisible by 2. So therefore 2 1s are 2, then 2 0s are 0, and 2 5s are 10. So when I divide 210 by 2, I will get 105 as the answer. Now further let's find the factors. So it is not divisible by 2 because it ends in 5. So let's divide this by 3, as 5 plus 0 plus 1 is 6. So it is divisible by 3. So let's start by 3. So 3 3s are 9. Okay, so remains 1. 3 5s are 15. So we have got 35. Now further 35 is divisible by 5. Okay, so therefore let's find the further factors. So 5 7s are 35. I'll use this. 5 7s are 35. Therefore, if you see 5 and 7 are not composite, those are prime. Now if you see the numbers or the digits which are rounded, the factors which are rounded are the prime factors, and when we multiply them together, we will get the answer 420. So let's list the factors. Therefore, factors of 420 are 2 into 2 into 3 into 5 into 7. Thus I have listed all the factors. Similarly, you can solve for number 72. See the next concept, highest common factor, and how to find HCF and LCM. This already taught to you, and the video of same is available on YouTube, okay, on my channel. So you can just go through the previous video. It was the first video uploaded on the YouTube. So you can see video part 1 to find the HCF. What is HCF? HCF is the highest common factor. The number which so it is the number that divides both the numbers without leaving any remainder. Okay, and for finding HCF, actually we have 3 methods. HCF by, I have listed here the methods. HCF by listing the factors, HCF by prime factorization, and HCF by long division method. Okay, so the finding HCF by prime factorization is already done, so that you have to refer the previous video, and listing by listing factors. So no need of this method, as this method you have already learned in 4th standard, so no need to repeat the same. And so this time we shall see HCF by long division method and prime factorization. As it is already done, I am not going to solve any example based on this. I will solve the example based on long division method. Now before finding the HCF, let's understand what are the properties of HCF. HCF of 2 or more numbers cannot be greater than any of them. Okay, so HCF will always be smaller, okay, smaller than the given numbers. If a number is factor of another, then their HCF is the smaller number. HCF of prime numbers is always 1. HCF of two consecutive numbers. Consecutive numbers means the numbers which follows one another. HCF of two consecutive numbers is always 1. Okay, so all these properties you will understand better when we solve the examples. So now let's solve this problem, that is find HCF of following numbers by long division method. So to do that, I'll choose the first example, that is 217, 231 and 259. So between these numbers we have to choose the largest numbers first. So this and this are the largest number. So among these, which is the greatest? 259. So let's divide 259 by 231 is our first step. Okay, so 231 ones are 231. We want the nearby number. The nearby number will be 231 ones are 231 only. So let's subtract now. After subtracting, we'll get 28 as a remainder. Okay, so further we have to carry the division until we get the remainder 0. So at this step, what we have to do is we have to divide the previous divisor. Okay, we have to consider the previous divisor as a dividend. So 231. We have to divide this 231 by 28. So 28, okay, when I multiply 28 by 8, let's see what answer I'll get. 8 is a 64. 4 here, 6 carry. 8 to the 16. 16 plus 6 is 22. Thus, I will get 224, which is the nearby number. Therefore, 28 8s are 224. Thus, let's subtract. So, from 1, 4 doesn't goes. So, from 11, 4 goes out, remains 7. And this will become 2. From 2, 2 goes out, remains 0. From 2, 2 goes out, remains 0. Okay. So, further, what is our next step? Again, here we have obtained the remainder. So, make this remainder as a divisor and take the previous divisor as a dividend, 28. So, 28 will be our next dividend. So, you know 7 4s are 28. 7 4s are 28. Now, from 28, 28 goes out, remains 0. Therefore, what we have obtained? Therefore, HCF of these two numbers, 231 and 259 is 7. 7 was the last divisor. When we divided this, we have got 0 remainder. Okay, so what about the next step? The next step is we have to divide this number by 7. Okay, so let's do that. 217 is the leftover number. Divide this by 7. Whatever HCF we will get of these two numbers, by that we have to divide this number, the leftover number, by 7. Next, 7 3s are. Next, when I multiply 30 by 7, okay, 7 zeros are 0, 7 3s are 21, I will get the nearby number, that is 210, isn't it? Okay, even you can do this way also. 2 7 30s are 210, and from this subtract. From 7, 0 goes out, remains 7. From 1, 1 goes out, 0. From 2, 2 goes out, 0. Now again I have got remainder. So make this remainder as a divisor and take the previous divisor as a dividend, 7. Now 7 1s are 7. From 7, 7 goes out, remains 0. So what number we have got it here? We have got 7. So therefore, now there are no numbers left to be divided, isn't it? Therefore, HCF of 217, 231 and 259 is 7. Okay, so 7 is a number which divides all these numbers together. Okay, hope you have understood this. Similarly, let's solve the next example, and here we have similarly the 3 numbers. So we have to choose the largest 2 numbers. So those are here. Okay, and let's find the HCF of, the first step is, let's find HCF of 336 and 420. So let's divide 420 by 336. So 336 ones are 336. From 10, okay, make it 10. make this 11, make this 3. So from 10, 6 goes out, remains 4. From 11, 3 goes out, remains 8. And from 3, 3 goes out, remains 0. Now this remainder will be divisor, okay, and this divisor will become dividend. Thus write this number 336. So now when I multiply, just see 84 by 4. 4 4s are 16, 8 4s are 32 plus 1, 33. I will get the number 336, means 84 4s are 336. Therefore 84 4s are 336. So from 336 goes out, remains 0. So what HCF we have got? The HCF is 84. Therefore HCF of 336 and 420 is 84. Now let's find the HCF of all these numbers. To do that, we have to divide 294 by 84. Let's divide the leftover number, that is 294 by 84. Okay, so we have to choose such a number or the nearby number which divides 294 exactly. Okay, so let's do that. Now if you see here, I have multiplied 84 with different numbers. Let's see which is a nearby number we'll get. So the nearby number we will get is 84 3s are 252. Okay, because 84 4s is 336, which is more than what we want, isn't it? So therefore we shall choose 84 3s are 252. So let's subtract. From 2, 2 goes out, remains 2. From 9, 5 goes out, remains 4. And from 2, 2 goes out, remains 0. Now again we have got remainder. So what to do? Make this divisor and previous divisor will be dividend. Take the 84 this side. So now 42. So by seeing only you can say that when we multiply 42 by 2, we'll get 84 answer. 42 2s are 84. So from 84 goes out, remains 0. So what is our HCF? HCF is 42. Therefore let's write the final statement. Therefore HCF of 294, 336 and 420 is 42. Hope you have understood this.